Hi viewers, in today's video we'll be talking about the theory of logarithm. In case this is your first time hearing the word logarithm and you want to find out what logarithm is all about. Logarithm is just a way of representing a number raised to a, like when I have 8, 8, we can rewrite 8 to be having a certain base 2 raised to power 3, because 2 raised to power 3 will still result to what? 8. Same thing with when I say 4. 4 can be written as 2 raised to power 2. How about 16? 16 can be written as 2 raised to power 4. So all these numbers, you can see that I'm raising a certain base 2 to a certain power such that it's giving me the initial result. So all this kind of method of representing a base raised to power a number to give a result we need is called the logarithm. Because the logarithm in other terms, you can just refer it to as what? Base. So when I say 2 raised to power 3, how do we write it to get back this? This is what we'll be discussing in this video. So for instance, when I have, let's just take this very one. When I have 2 raised to power 3, normally from indices, you can just rewrite this as 2 times 2 times 2, right? And 2 times 2 times 2 is 2 raised to power 3. But this time around, I need the result that it will just give me straightforward. How do we do that? I'll write a certain formula we'll be using, because I'm sure maybe you might have heard of it sometimes back or you've forgotten about it. So for instance, when you have a certain, let's say log of, let's say m with a certain base, let's say a is equals x. Let me interpret what this whole thing means. I'm saying log of m raised to power, this very base you are seeing is the base we have here. 8 is equals 2 power 3, right? So this a you are seeing is same thing as the base I have here, which is what? 2. This 3 you are seeing, the power you are seeing here means what you are raising the whole thing to. So this m means the number here. So when I have log of m base a is equals x. This x means I don't know what the result will be, right? So for instance, let's see, how do you write this? When I say, let's write the whole of this. Log of 8 base 2. You can see how I write it. Log of what? 2. Log of 8 base 2, meaning 2 is the number I need to raise. What the question here now is, what is the number such that I'll raise 2 to that number to give me 8? That's what this whole question is all about. So this equals x you are seeing me putting. In mathematics, anything we don't know, we call it x, right? So I don't know the number that I'll raise this very 2 to get the 8. So I'm calling it what? X. Then we will now resolve it. So how do we resolve to get the number? I'll raise the number we are talking about here to get the result. This is the formula. When you have log of m base a is equals x, the first thing you just do is bring your base a, you bring the number here, x is equals what? M. If you can rearrange and write the whole of this in this, then you can solve it. As you can see, let's do something here. I'll be referring back to our indices that we've treated before. So we have log of 8 base 2, right? That means you relate with the formula here. Assuming you are just giving this question to solve, you relate it with what you're having here, right? So this is log, we have log. You can see A is what? 2. So that means A is equals what? 2, right? What is our M? As you can see, M is what? 8. That means our M is equals 8. X is just x, right? We are trying to solve for x. So relating with the formula I gave such that I said you can get back your result, let's compare and see. A raised to power x, which is 2 raised to power x, right, is equals, we said m. This is equals m. And from our indices, we all know how to do this, right? There's a certain number here such that if I raise it to base 2, it will give me 8. What's that number? You can just think of it. Intuitively, we all know that 2 raised to power x is equals 2 raised to power 3, right? Because 2 raised to power 3 we said is 8 recently. So that means we have the same basis. And from law of indices, when you have the same base, you can just equate the power, right? I have 2, 2, that means I'll just equate the power. So that means if I'm equating the power, you can just be like, this one is cancelled out. This is x is equals what? That means x is equals what? 3. That's what I mean here. Now look at 8 is equals 2. I didn't even mention it, but based on how we solve it, we arrived at x is going to be 3. That means 2 will be raised to power what? 3. And as you can see, this is the result. Let's test for this very one. This is base 4, right? So when I have log of 4 to a certain base 2, If you are just given this kind of question and you are told to solve it, how do you do it? You don't know what the result is, so we call it what? X, because we don't know it, right? So immediately you are done with that, just relate it with this formula here. You compare. Your A is what? A is equals 2, right? As you can see, our M is equals 4. X is X. Immediately you are done with comparing with that, just put it in this format. I'm going to have 2 raised to the power X is equals 4, right? So from this point, we all know that there's a certain number that will raise to give me 4. What's that number? But mind you, when doing this, you have to be focusing on what you are having on the left hand side, right? Because I have to raise it to the same base such that I can just equate the power. So this time around, I'm having 2 raised to the power x is equals, I have to bring 2 first because 2 is what I'm having here such that I can equate. This is 2 raised to the power 2 because 2 raised to the power 2 is what? 4. So the bases are same. Equating the power, I'm going to have x is equals 2. And as you can see, that's just how to do these kind of things. But there's a problem you can face sometimes. They might just decide to give you a number with a different base. For instance, let's say a decimal. Let's say we have you are given log base 5 of 0.04. As you can see, this time around we have a decimal, right? You'll be confused. Okay, we've treated whole numbers. How do we treat this decimal? Calm down, it's still same thing. It's all about how you manipulate what you're having in the decimal. And as you can see, you all know that we can convert this very decimal to a what? To a fraction, right? Because 0.04 is same thing as 1 over 25, right? So that means we can write this to be 1 over 25. But the thing is, we have so many things to manipulate here. So let's see. We don't know the result. This is x, right? So how about this? You can say log of base 5 is 1 over what? 25, which is equals x. I didn't do anything. I just rewrite the whole thing, right? So from this point, what is our a? A is equals 5, and our m is equals what? 1 over 25, because that's exactly what our m is, comparing with the formula I give. We'll be making reference, like I said, with these very formulas very well. So if we want to relate it with this, I'm going to have, this is 5 raised to the power x, right? That's what we said recently. Is equals, this is m, but m is 1 over 25, right? So, like I said, treating logarithm, you have to be relating it very well with indices. So, same thing will be happening here. We are going to have 5 raised to the power x is equals, this can be written as 1 over 5 raised to the power 2, because 5 raised to the power 2 is what? 25, right? So, but there is another property that says when you have 1 over a, you can write this as what? A raised to the power minus 1, because you just flip it up, right? If it comes down, if it were a square, you write minus 2, isn't it? So that means I can write this in that form. How do we do it? I'm going to have 5 raised to the power x is equals 5 raised to the power minus 2, because 5 raised to the power minus 2 can be rewritten as 1 over 5 raised to the power 2. And as you can see, we've arrived to a point such that the bases are same. So what's the next move? It's just to equate the power. So our x is equals what? Minus 2. And as you can see, it's very easy, right? So we'll be making more videos on to see how we can treat more fractions, more decimals, and so many of it. So thanks for watching. Don't forget to subscribe and watch other videos, because you'll be missing out if you don't watch. Thank you.